Hi guys, as we anticipated in the previous video, the trick for making op-amp useful devices is by applying what is called negative feedback. It's a technique where some voltage of the output voltage is sent back to the inverting terminal. This voltage can be sent through a resistor, or capacitor, or a complex circuit, or through a wire. So, our well-known formula, the open loop output voltage, which we are known to be needs to be modified here, because now V minus, that is the inverting terminal, receives some extra voltage from the output terminal. So we will replace V minus with where F is a fraction of the voltage sent back from V out to the inverting terminal. So our final or our new open loop voltage expression will be the reason why we've introduced the fraction F into the open loop expression here is to provide us with a bit of basic understanding of how negative feedback work. But the trick to calculate negative feedback circuit is as follows. So if we treat the op-amp as an idle device and rearranging the open loop formula that we know, we realize so let's rearrange the open loop formula that we know, this one. So let us write it like this, in this way. Divide both sides by the open loop gain equals to so we realize that the left side of this equation goes to 0 because we know for an ideal op amp the open loop gain is infinite and any value over infinite is 0. So we get the expression so V plus minus V minus equals 0. This result brings us to a fourth rule that we need to remember, that whenever an op amp senses a difference voltage between its inverting and non-inverting inputs, it responds by feeding back as much current or voltage through the feedback network as is necessary to keep this difference equals 0. So with this feedback technique, anytime the op amp sent a differential voltage in its input, it responds by feeding back a voltage or a current necessary to make that difference equals 0. Let's remember that this rule is only applied for negative feedback circuits only. So only for negative feedback. So let's see some examples of negative feedback circuits. Let's consider the simple one example. So op amp so here we've used a simple wire for the negative feedback network. So we have a straight connection from the output to the input terminal, the inverting input terminal. So since we are dealing with a negative feedback, we can apply rule 4. So for this example, we are asked to solve for the gain. So by applying rule 4, which tells us that anytime the op amp sends a voltage difference, it responds by supplying the necessary voltage in its non-inverting, in its inverting input terminal to make the difference equals to 0. So the V plus minus V minus, according to rule 4, should be equals to 0. So if this is the case, then V plus should be equal to V minus. And from this example, we note, or we can see that V out is directly connected to V minus. Therefore, V minus is equals to V out. So V plus is equal to V minus and equals to V out. So, and we know that V plus here is connected to V in. So we can say V out as well is equal to V in. So the gain will be V out over V in, but since V out is equals to V in, the gain is equals to 1. A gain of 1 means that there is no amplification. The op amp's output follows. In this case, since there is no amplification, the op amp's output follows its inputs. So whatever we supply at the input, we get the same thing at the output without or with no changes or modification. At first glance, it may seem that this circuit is useless. However, it is important to recall that an op amp's input impedance is huge while its output impedance is extremely small. These features makes this circuit useful for circuit isolation applications. So a gain of 1 is useful for circuit isolation applications. Circuit isolation. In other words, this circuit acts as a buffer. That is why it is called a buffer or the unity gain amplifier. But with a rare op amps, it may be necessary to throw in a resistor in the feedback loop. The resistor then reacts to minimize voltage offset errors caused by input bias current or leakage. The resistor of the feedback resistor, this case, should be equal to the resistor. So, like for a rare op amp, we should have something like this. And here, so this is the feedback resistor, and as we say, it should be equal to the source resistor for a rare op amp. So, in the next video, we will see how an inverting amplifier works. See you in the next video.